Okay, Assalamualaikum everyone. Okay, so this is a new topic. Okay, so after LU decomposition for solving OD linear simultaneous linear equation. Okay, so I'm going to show another application for LU decomposition. Okay, which is to find the matrix inverse. Okay, or inverse of matrix. Okay, so I'm going to share to you the slides. Okay, so these materials you can refer to the e-learning. Okay, so in this screen it shows how this LU decomposition method for finding matrix inverse. Okay. Okay, so let's consider if we have this matrix A is given here. It is 3 by 3 matrix. Okay, so you already learned in previous subject in mathematics 1 how we can find the inverse of matrix using uh, ERO method, okay, or we can have uh, other kinds of method using sum of cofactor, okay. But this one is a numerical method which is based on the LU decomposition. Okay, so this A is given here, so we want to find the inverse of this matrix A. Okay, so the inverse of the matrix A is being denoted by A to the power negative 1. Okay, it's just a notation for negative 1, but it is means inverse of matrix. Okay, so this example is based on 3 by 3 matrix. Please take notes about the steps that I will explain after this. It looks similar to the way how we find the solution for simultaneous linear equation. Okay, but this time is to use uh, matrix inverse. Okay, so the first step, we write down the original matrix A on the left hand side and find the upper matrix. Okay, so U is the notation for upper matrix using ERO, elementary row operation. Okay, so you have learned this step 1. It's exactly the same uh, when we want to find the matrix U for solving the system of linear equation. Okay, so I'm not going to explain the steps 1. Okay, same goes for step 2. Find L, which means the lower matrix. Okay, so in step 2, find the lower matrix. So we start finding using uh, the formulation. Okay, find the blue color and then find the purple color later on, and then we write down the matrix L. Okay, so matrix, lower matrix is a matrix containing the lower part of the matrix are non-zero and the diagonal entries are 1. Okay, so step 1, find upper matrix. Step 2, find lower matrix. Okay, so step 3, it is a bit different. Okay, so step 3, we find and perform Ly is equal to I1 and then apply the forward elimination. Okay, L means lower, Y is our created matrix Y, and I1. So I'm going to explain now for I1. I in matrix is means identity matrix. Okay, so for 3 by 3 matrix, okay, for 3 by 3 matrix. So if the matrix, we have matrix A, the size is 3 by 3, 3 rows and 3 columns. So the identity matrix is equal to this form. Okay, so this is I1. This is I2. This is I3. Okay, so the 1, 2, 3 is the label for the column. Okay, so that's why in step 3 here, this is I1. Okay, so just take it I1, 1, 0, 0 in this identity matrix of 3 by 3. So if we have matrix A whereby the size is 4 by 4. So the identity matrix will be 4 by 4. Okay. So whereby the upper and lower part matrix in the identity matrix are 0 and the diagonal part is 1. Okay. So then we solve it to find out what is the value of y1, y2, y3. Okay, so this step is based on forward elimination. Okay, so we start find y1 and then if we write down equation for the second row here, okay, as this one, equal it, and then we solve for y2, then we have this value. Okay, and then we write down the equation for the third row as shown here. Okay, let it equal to 0, which is here, and then we solve for y3. Okay, so the next step is to perform ux equal to y. Okay, so the next step, once we have find out what is y1, y2, y3 using I1. Okay, so the next step is to perform ux equal to y and apply backward substitution. Okay, so this is our matrix U, upper matrix. Let it equal uh, U times X, let it equal to Y. Okay, so this Y is comes from Y1, Y2, and Y3 we have in previous step 3. Okay, so we write down like this one. And we solve for X2, X1, X2, X3. Okay, so in this step we apply backward substitution. So we will start finding the solution for X3 first. Okay, so this is comes from your row number 3. Okay, from the last one, so solve it for unknown, then we have x3. And then we do similarly for the second row, we write down equation like this one. Okay, so x3 substitute here. And then solve for unknown, we have x2. Now here we have solution for x2. And row 1, from row 1, let it equal to 1. Okay, solve for x1 after we substitute the value of x3 and x2 that we have just now. Okay, this is the value that we have find out previous step. Then solve for x1. Okay. Okay, so uh, this is not the final steps yet. There are some steps that we are going to repeat. Okay, but from the step 4, okay, so we know that in matrix inverse. Okay, so we have matrix A. So this is a notation for matrix A. Okay, so the steps that we have in this step 4 is our part of the answer, whereby we'll write down like this one. Okay, x1 is here 0.33249, then negative 0.00518. Then we have negative 0.01008. Okay, so they are remaining columns that we need to find out. This is the answer that we have find out for the first column in the matrix inverse. Okay, so there are 2 more columns that we need to find out. Okay, so because of this, we need to repeat the step. Okay, to find the remaining 2 columns. Okay, so after this step 4, we are supposed to repeat steps 3 and 4, okay, as shown here. Okay, however, there's some changes. Okay, so we start repeating the steps 3 and 4 as shown here. Okay, so the green color is the repeating step for the I2. Okay, perform Ly equal to I2 and apply forward elimination. Okay, so L means lower, Y is our crater matrix, that is, and then we have I2 that is the second column that comes from our identity matrix. Okay, then we solve for the unknown. Okay, so we apply forward elimination here. So we start finding the value of y1 as shown here. Then write down the equation for y2. Let it equal to 1. Then solve for unknown y2. Okay, so previous we have y1 equal to 0. So substitute, then we have the value of y2. Okay, then from row number 3, we write down the equation as here. Let it equal to 0. Solve for the unknown y1 after we substitute the value of y2 and y1 into the equation. Okay, so we have y3 which is equal to this number. Okay, so after that, u x equal to y. So y is the one that we calculated previously, y1, y2, y3. And then we solve by looking at the third row, okay, based on the backward substitution. So from the third row, we write the equation that is equal to this one. Then solve for unknown x3. After that, we write down the equation for row number 2. Let it equal to 1. And then solve for unknown x2. Okay, and then we do it until the first row. Write down the equation. Substitute the previous value that we have find out. Okay, then solve for x1. Okay, so we have the term here x1, x2, x3. Okay, so then we write down these numbers in our second column of matrix inverse. Okay, so here 0.00494. So we are going to write down here 0.00494. Okay. And for x2, so right down here 0.1429. Then x3 0.00271. Okay, so we have the answer for second column. Now we need to find out one more. Okay, the last column. Okay, so we need to repeat again steps 3 and 4. Okay, so using the value of I3. Okay, so I3 is the one in the third column of our identity matrix. Okay, so this is the steps. L, lower matrix, Y is here equal to I3. Okay, I3 is 001. And then we apply forward elimination. We have Y1, Y2, Y3. So after we find out that these three values, perform, this is the last step, perform Ux equal to Y and apply backward substitution. Okay, so we start, for this last step, we start with the third row. Is given equal to 1. Okay, so for unknown, so we have this x3. Then write down the equation based on second row. Let it equal to 0. And solve it. And then we have this value of x2. And the last one, we write the equation by referring to first row. Okay, substitute values of x2 and x3. And then we solve for the unknown x1. Okay, so this is our answer for the last column. Okay, so it should be written here. So it's split x1, x2, x3. Okay, so we have, this is the final numbers. Don't forget to write down the inverse. Okay, as given here. Okay, so I have shown to you the each elements in the inverse of matrix based on the color. Okay, so you can see that the blue color represent on which step. Okay, the green color comes from the previous one, then the red color comes from our answer in the early step. Okay, so that's all for the example for the LU decomposition to find the matrix inverse. Please refer to the list of tutorials, okay, uh, for you to solve as a tutorial questions. Okay, thank you.